3IATLAS has returned, but its streak is glowing brighter, pulsing with strange energy after its trip behind the sun.
China has just captured rare images of 3E Atlas, and the revelation is deeply unsettling. What was once considered a distant interstellar curiosity out there now appears far stranger than expected. The Tianwen-1 Mars orbiter on October 3, 2025, recorded a faint irregular form with a compact core and no visible cometary tail. Rather than the diffuse misty halo caused by evaporating ice and drifting debris, the object reflected light in sharp, uneven flashes, the kind of glints one expects from metal, turning slowly under an unseen force. Even from nearly 29 million kilometers away, the object did not appear chaotic or crumbling. Instead, it looked structured, stable, as though its shape held purpose. This is 3E Atlas, the third known interstellar object ever observed by humanity under the Atlas detection program. An ancient wanderer, likely billions of years old, it passed closest to Mars. On October 3, Chinese scientists seized the moment to capture a sequence of images, unlike anything recorded before, but the final images were only possible because the team rehearsed the capture in advance. On October 1 and 2, they conducted trial imaging runs to confirm the object's orbit and calibrate Tianwen-1's high resolution camera. After those tests, the orbiter captured the official frames on October 3, timed to the precise moment 3E Atlas made its nearest approach. The camera was tuned to perfection, and the result was an image that has left scientists wondering whether this so-called visitor is natural at all. 4 months before these releases, both NASA and China withheld new information about 3E Atlas. Observatories tracked it, researchers debated it relentlessly, yet no one spoke publicly. That silence felt intentional, strategic, as though something was being confirmed behind closed doors. Then, without warning, NASA issued a short report on November 6. Instruments had detected an anomaly in the object's tail patterns of brightness and motion that did not match any known comet behavior. The timing was precise, deliberate, and the next day, China released its captured images and officially described the object not as a comet or asteroid, but as a visitor. The sudden end to silence, the mirrored announcements, and the language used raised unsettling questions about what prompted both nations to speak. The visitor is faint, barely magnitude 67. Just beyond what the naked eye can see. It moves fast and quietly shines weakly, making it extremely difficult to track, but UNAS's report carried weight far larger than its length. Spectrographic and photometric data revealed irregular fluctuations in the tail of 3E Atlas. A normal comet tail forms when sunlight heats frozen gases, causing jets of vapor and dust to burst outward in predictable patterns, but this tail shifted intensity without any connection to distance from the sun or rotational phase, suggesting a motion not driven by sublimation at all. Researchers inside and outside NASA recognized the pattern. Astrophysicist Avi Loeb had already suggested that 3E Atlas, like the earlier interstellar object Oumuamua, might be experiencing non-gravitational acceleration. He argued that such deviations in trajectory could indicate solar radiation pressure acting on a surface with unusually high area relative to mass. In other words, something broad, thin, and possibly engineered. Something built to move with light itself, something that does not behave like a comet. Essentially, the object may not be a solid chunk of ice or rock at all, but something extremely thin, more like a sail panel or sheet than a natural fragment. UNASA's acknowledgement of the anomaly did not openly endorse that interpretation, but by confirming the underlying data, the agency effectively reopened the discussion. The tone was cautious, even restrained. The report included no images, no released spectrographic plots, only a distilled summary of readings. It stressed repeatedly that the observations required further verification before any definitive interpretation could be made. Even so, the mere publication of the report represented a shift. For months, UNAS's public communications on 3E Atlas had been limited to routine tracking updates. Suddenly, the object was back in discussion not because of its position, but because of its behavior. Less than 24 hours later, the Chinese National Space Administration released its own announcement, accompanied by 3 images from its high-resolution imaging camera aboard the Mars orbiter. The images were dim, grainy, and low in contrast, yet they drew immediate attention from astronomers. Worldwide, the object did not display the soft, dispersed halo one expects around a comet's core. Instead, it appeared irregular, its reflectivity uneven, with sections that flashed sharply. Some observers described the reflections as specular miraclita, than the scattered muted shimmer, typical of dusty ice. The wording of the accompanying statement was as notable as the images themselves. The object was described as a visitor from interstellar space, a phrase that avoided familiar labels such as comet or asteroid. Chinese scientists noted that preliminary light curve analysis suggested an uneven surface and variable orientation, but declined to offer interpretations. Still, the choice of the word visitor was deliberate enough to draw attention from journalists, linguists, and researchers alike. Comparing the two disclosures reveals both overlap and divergence. NASA emphasized physical dynamics, tail composition, radiation pressure, and anomalous energy distribution. China emphasized visual and optical properties, surface reflectivity, contour, and the absence of particulate haze. Neither data alone is conclusive, but taken together, they form a picture of an object that does not comfortably fit any known natural category. UNAS's report suggests that 3E Atlas is moving in ways not solely determined by gravity or sublimation. China's imagery hints at surfaces that may be smooth, planar, or structured. The convergence does not prove artificiality, but it reopens questions that many had considered closed. To understand why this is significant, it is necessary to step back. 3E Atlas, detected in early 2024, is only the third confirmed interstellar object ever observed passing through our solar system, following Oumuamua in 2017 and Dviborosov in 2019. Like its predecessors, it travels on a hyperbolic trajectory, meaning it is not gravitationally bound to the Sun, and will eventually depart. Initial observations suggested a faint tail and hints of volatile materials, leading researchers to classify it as a comet. But as more data accumulated, inconsistencies emerged. The rate of brightness change did not match standard outgassing models. Its velocity profile contained small but persistent deviations from predictions. By mid-2024, multiple observatories had gathered enough evidence to confirm these irregularities. Despite increasing interest, both NASA and China withheld detailed imagery for months, citing calibration and verification protocols. The sudden, nearly simultaneous disclosures in November felt intentional. One interpretation is that UNAS's confirmation of the tail anomaly compelled China to release its images to avoid appearing secretive. Another suggests that both agencies reached similar internal conclusions and chose to disclose in coordination. A third, more speculative view proposes both detected new information, possibly from radar echoes or spectroscopic signatures that required acknowledgement. Whatever the reason, the timing stood out, and what makes 3E Atlas compelling is its most perplexing physical trait: its tail does not consistently align with the direction of the Sun, a behavior never observed in ordinary comets. This misalignment suggests forces acting across its surface that are persistent, as though shaped by something other than ice, dust, and gravity, in a way that defies expectation. Instead of behaving like a simple chunk of rock or ice, 3I Atlas appears to shift its orientation periodically, as if responding to internal mechanisms or a surface built to reflect light in controlled patterns. The brightness of its core does not follow the steady rhythm expected from rotation alone. It fluctuates with a repeating signature that suggests something else is influencing its motion. Meanwhile, spectral readings from several observatories reveal a composition richer in metal than expected for a comet, lacking the organic traces typically found in icy bodies formed in the outer regions of a solar system. The irregularities echo the debates that surrounded Oumuamua 7 years earlier. That object also displayed no acceleration without any visible outgassing, and its elongated, possibly flattened, shape allowed light pressure to influence its path. At the time, most astronomers proposed natural explanations: frags of nitrogen ice, a hydrogen iceberg, or an unusual shard of planetary crust, yet none of those models matched every observation perfectly. Astrophysicist Avi Loeb argued that the simplest explanation should not be dismissed simply because it challenged expectations: a thin reflective structure, not naturally formed, but manufactured. 3I Atlas appears to be following the same pattern, but this time with clearer data and more direct observation. Unlike Oumuamua, which was already leaving the inner solar system when telescopes began to track it, 3I Atlas passed close enough to Mars for detailed imaging. The combination of UNAIS's tail motion anomaly and China's optical imagery has given scientists a clear yet still incomplete picture. If the object's reflective properties are truly metallic, and its acceleration is independent of mass loss, then it may represent either a category of interstellar material never previously recorded, or something far more deliberate. Possibility fuels both public fascination and institutional caution. The idea that 3I Atlas could be artificial is extraordinary, but it arises directly from the observed behavior: a thin, non-outgassing, light-reflective structure that accelerates softly under sunlight is exactly what a solar saline established human engineering concept will do. If another civilization developed such technology millions of years ago, fragments or probes could drift across interstellar space, just as debris from human missions will one day leave our own system. Loeb's framework does not treat such objects as active spacecraft, but as relics, technological fossils left behind by exploration long faded. Yet skepticism remains strong. Many astronomers emphasize the limits of current data. The fluctuations in brightness could be produced by an uneven surface or a wobbling axis. The tail anomaly might result from mirror impacts, magnetic fields, or other interactions not yet accounted for. Without high-resolution spectroscopy or closer-range imaging, no definitive conclusion is possible. NASA and China have both acknowledged this uncertainty, noting that 3I Atlas is now drifting beyond optimal observation range as it moves outward toward deep interstellar space. The term visitor used in China's release has become a point of debate. Some interpret it as a simple expression of curiosity, others view it as a careful signal that Chinese researchers consider the object different from standard cometary bodies. Meanwhile, pressure on NASA has intensified. Media outlets and scientific journals are calling for the release of all imaging data, including possible captures from the James Webb Space Telescope. NASA states that analysis and calibration are ongoing, but critics argue that withholding the data only increases speculation. In response, independent observatories have begun publishing their own light curve analyses, many of which confirm that the object continues to behave in unusual ways. 3I Atlas recedes from the inner solar system, the window to study. It is closing. Astronomers estimate that by early 2026, it will be too faint for meaningful observation. This urgency may explain the sudden timing of the announcements. Both agencies understood that whatever 3I Atlas is, the time to examine it directly is fleeting. Once it leaves, humanity may not see another interstellar object like this. For decades, the debate now centers on interpretation. If 3I Atlas is natural, it represents a form of interstellar debris unlike anything previously seen. A fragment shaped by forces near a dying star, or a collision in a distant system. If it is artificial, then it would stand as the first physical evidence of technology beyond Earth. Even if only a broken remnant, between these extremes lie countless possibilities: an unknown mineral structure shaped by cosmic radiation, a semi-eroded magnetic dust formation, or a cometary fragment with an unusual surface chemistry. What is clear is that 3I Atlas has challenged existing models of how interstellar material behaves as it moves through our system. Both UNOSA's anomaly data and China's imaging indicate that our current understanding of cometary physics may be incomplete. Whether that gap points to unknown natural processes or evidence of engineering is what scientists will continue to debate. As 3I Atlas fades into darkness once more, it leaves behind unanswered questions. Why did both agencies break their silence almost simultaneously? What prompted the shift in tone? And what does the word visitor truly mean to those who used it, the answers may only come with the next object that drifts in from between the stars. Then 3IATLAS remains what it has always been. A mystery passing through the solar system, offering just enough to question what we think we know.